Greetings and welcome to my calculus lecture series. For this series we will be using the third edition of this Calculus Graphical, Numerical, and Algebraic series textbook. We will kick things off with Chapter 1, Prerequisites for Calculus. We will basically be reviewing initially some basic mathematical concepts that you should be familiar with in order to fully grasp calculus down the road. First, we will be talking about lines, then functions and graphs, exponential functions, parametric equations, functions and logarithms, and finally, trigonometric functions. Section 1.1 will be dealing with lines, namely increments, the slope of a line, parallel and perpendicular lines, as well as equations of lines. The first very basic mathematical concept is increments. If a particle moves from the point x1, y1 to the point x2, y2, the increment in its coordinates are delta x equals x2 minus x1 and delta y equals y2 minus y1. This just means that if we have an xy plane like this, and we have a first point and a second point, we can find the increments by subtracting, and we can call this point number 1 and point number 2. I know that's not very clear, but we can find the increments by using these equations right here. It's basically how far you have traveled in regards to the x and y coordinates. So a very basic concept. It's just basically showing us if I have 2 points on a graph, how far I have moved. Next, we have the definition of a slope of a line. So let P1 x1, y1, and p2, and those are points, p2, x2, y2, be points on a non-vertical line L. The slope of L is m, which is equal to rise over run, delta y over delta x, and also right here, so delta y over delta x, those are the increments that we just covered on this previous slide. And so that's known as the slope of a line, and it is frequently written as m. So if we have a xy plane like this, and we have a line that's going up this way, the slope tells us how steep that line is going to be, and that's given by delta y, or the change in the y direction over a certain interval of this line, so that would be right here, delta y, divided by delta x. And that is equal to m, or the slope of a line. Now, if m is a high value, has a higher value, then our slope is steeper. It might look a little something like this. But if m has a lower value, then our slope is not going to be as steep. It might be something like this or something like this. So again, if we have a high m value or a high slope value, our line is going to be steeper. So just think of the slope of a line as its steepness. And that can be better illustrated right here, where we have point 1 and point 2. And this triangle right here off to the right is the slope. So we have the change in y, which would be y2 minus y1. The change in y over the change in x, divided by the change in x, which would be x2 minus x1. If we divide those two things, as is the case down here, we get the slope of this line. So very basic concept right there. Next, we can talk about parallel and perpendicular lines. In figure 1.2, we have an example of two lines that are parallel. It means that if they go on forever, they will never touch. Another way of putting that is that they have the same slope. So if two lines have the same m value, aka the same slope, they are said to be parallel, and they will never touch even if they are endless. You may see that written as such. We have L1, L2, and this double vertical bar in between them. That means that they are parallel. And again, it means that M1, the slope M1 and M2 are equal. So this slope right here is equal, and this slope right here is also equal. What this also means is that the angle that is formed between each line and the x-axis is going to be the same if the lines are parallel. Now, a perpendicular line is kind of the opposite of that. It's where we have two lines that cross each other and form a 90-degree angle, like this. And the textbook definition of that occurrence is if two non-vertical lines L1 and L2 are perpendicular, their slopes M1 and M2 satisfy M1 times M2 equals -1. So if we have two lines and their slopes, if multiplied together, equal -1, we have a perpendicular set of lines. So each slope is the negative reciprocal of the other. So mathematically it looks like this. If M1 is equal to -1 over M2, and M2 is equal to -1 over M1, then the lines are perpendicular and they form this shape right here where we have a 90-degree angle between the two lines. This is also sometimes called two lines being normal to each other. So if you ever hear the expression that two lines are normal to each other, or a line is normal to a surface, it means that it's perpendicular and they form a 90-degree angle with each other. Now, there are several different ways to write equations of lines. The first of which is this point-slope equation, which we can see right here. Point-slope equation, where we have y equals m, and m is the slope of the line of x minus x1 plus y1. So if we have a certain point here, and we also know the slope of the line passing through it, we can figure out what the equation of the line is. That's useful, once again, if you have one point and a slope to figure out what the line's equation is. The next equation we have is slope-intercept equation, which is right here. This is probably the most common one you're going to see. Y equals mx plus b. And this tells us if we have a slope value, m right here, and b, which is going to be a y-intercept, meaning where that line crosses the y-axis, we have y equals mx plus b, that's slope-intercept form, or a slope-intercept equation of a line. And again, that's probably the most common one you're going to see. The next one you'll see here is the general linear equation. Now, this one's not as common, but it's also pretty useful, where we have ax plus by equals c. And this can only apply when a and b, the coefficients, are not both 0. There are other equations of lines, but these are the most rudimentary, basic ones, of which this slope-intercept equation form is the most common and that we're going to deal with the most. So let's dive right into a quick example right here. First, we're going to find the line equation for the points a 1, 2 and b -1, -1. And that should actually be a comma right here. My apologies. So line equation, again, like I said, this center one right here is the most common. And so if you hear the term line equation, generally that refers to this one right here. So we're going to take these 2 points and we're going to put them into slope-intercept form, or into the slope-intercept equation. So first thing we need to do is that we have to calculate the increments. And remember, the equations for increments are delta x equals x2 minus x1. So again, point B is going to be 2 and point A is going to be 1. So when we're talking about x2, we mean -1. And then when we're talking about x1, we mean +1, because that's the case for points A and B. So delta x is x2 minus x1, which is equal to -1 minus +1, which is equal to -2. So we have our x increment. Now let's find our y increment. Same deal there, except we're going to have -1, because y2 is the y coordinate for B, and y1 is the y coordinate for A. So we're going to have -1 minus 2, which is equal to -3. Next, we will calculate the slope, otherwise known as m, and that is, of course, rise over run. So we have m equals rise over run, which equals delta y over delta x, which is -3 over -2. So this guy on the bottom divided by this guy up here. And that gives us a slope value of 1.5. All right, so next we're going to use the point slope equation, which was this first one right here. And we're not going to stop there. We're going to first use this one to get this second form right here. And that's going to entail plugging in all of our values into the point slope equation, which is pretty simple. You just put in 1.5 for m, and then 1 for x1 and 2 for y1. Then finally, we simplify this down and put it into slope-intercept form. So it's kind of important to catch that little detail. The slope-intercept form, like I was saying, the most common form of the equation, and I didn't reveal this until now, is actually just a simplified version of the point-slope form, which gives us a slope-intercept form equation of y equals 1.5x minus 1.5 plus 2. Actually, that can be simplified down a little bit more, until we get y equals 1.5x plus 0.5. So that's our line equation, our slope-intercept equation for these 2 points. So if you want to create a line and a line equation, all you really need is just 2 points. Okay, now the next thing we're going to do here is we're going to find the slope and y-intercept of this equation right here. Now this should look a little bit familiar, and that's because it is in the form of the general line equation. Again, this is a little bit more rare, but we're going to use this to figure out what the slope and y-intercept is of that other equation. So the first thing we're going to need to do is let's isolate y. So we're going to isolate y, and we're going to do so by first subtracting 3x from both sides and then dividing both sides by 4 in order to get this form right here. Now this should also look familiar. This is actually in slope-intercept form. So again, you could kind of think of this form right here. You could think of slope-intercept form as sort of a simplified version of this equation right here. So we just isolated y to get it into slope-intercept form, and simplify it down further by dividing 12 by 4, which is of course just equal to 3. And then all we have to do is define slope and y-intercept, and that's very simple. Of course, the slope of this line is going to be negative 3 over 4, because whatever's multiplied by this x out in front is m, is the slope, if the equation is in this form. So m is just equal to negative 3 over 4. And then the y-intercept is very simply this guy at the end right here, positive 3. So the y-intercept is positive 3, this guy at the end. And please be aware that this is sometimes also known as b. The y-intercept is sometimes known as b. So we have a slope of negative 3 over 4 and a y-intercept of b. And that would form a line that looks a little something like this, where we have a negative 3 over 4 slope, and this is just a very rough sketch, and then a y-intercept of 3. So just be aware that the y-intercept is where it crosses the y-axis. Simple enough, so let's move on to section 1.2.